So on this slide, did you guys have any issues? Any major issues that came up or questions that you were like, what am I supposed to do with this or anything like that? No? Okay. And if you're just not speaking up, like you guys saw just a second ago on the screen, this is going to be the slide that you are still using the first day's material, which is Ape Man. So you can rely on atomic number, protons, and electrons all being the same value. And that's just because they're all neutral. They don't have any charges. You don't have to worry about anything like that. Okay? The man part is your mass number minus your atomic number, which we've hopefully gotten used to that's protons, right? And that's going to give you your neutrons. So mass number minus protons gives you neutrons. Another way to write that, and honestly, the only way that I really think of it, because I think I don't think of man, I just tell myself, okay, protons are in the nucleus, neutrons are in the nucleus. That gives me a mass number. Okay, so if that makes more sense to you with this chart, you might use that. I know sometimes our brains switch off and we're like, atomic number, what is that? What is that? What is that? It's the protons. It's your protons. All right. So if you can just start using that word interchangeably, protons and atomic number, you shouldn't be struggling too much with that. One thing I do want to clarify, because this question did come up yesterday during in emails and in tutoring, this atomic mass, this is your, I guess I shouldn't write in that color. This is your mass number, okay? I apologize for the incorrect vocabulary there. That was really misleading. Didn't catch it until that was brought up. So this is your mass number, not from your periodic table. So I expect you for this column right here that you are using your protons and neutrons to add them up. Does that clear up at least that part a little bit? Okay. And if you were using your periodic table, it's not a big deal. But you would have to be rounding it down, rounding it down to the nearest whole number to kind of get that mass number. But this is more reliable, and this is what our intention was on this slide. And I apologize for the miswording there. Okay. All right. So I will record whatever help we're doing on this little video, and you guys will be able to kind of handle it that way. So hopefully. Let me click. This slide seems to be the one that I got like tons and tons and tons of emails and messages and things about, okay? So one thing I do want to point out and apologize for was this part, that I threw the word ion at the top part. Did not mean to do that, and I apologize. But I will go over it so that you guys can get that answer, and that'll at least cover a little bit of both things. So just to show you, because I think the first row itself looked a little overwhelming, right? Because you have all these blank squares and you're like, well, where do I start? So let's start with that one, and then I'll go to the chlorine ion, and that way if people have to go, they can go. Okay, so for calcium 40. So first thing to notice is that this is in isotope notation. It's also called hyphen notation. Hyphen meaning, or spelled like this, like hyphen notation, okay? And so that tells you that this is not a minus sign. So this little dash right here, that's not a minus sign. That is a hyphen, okay? Because that question came up as well. So with this hyphen notation, we have calcium 40 written out. So when you go to write in your nuclear symbol, I'm just going to zoom in here, kind of make it bigger. And I realize some of these were a little blurry. Let me know if ever anything is blurry, and I can clear it up what it is that you're looking at. Okay, so for calcium 40, for your nuclear symbol, you should have started with Ca, okay? This number right here, this was your mass number, okay? Remember, mass number is made up of protons and neutrons. So this mass number takes care of talking about which isotope we're dealing with, because the thing that's changing with isotopes is your number of neutrons, because that's what changes the mass number, right? So that's how we define these. That's why we name them that way. So your mass number always goes on top. So this 40 would go up here. And then your atomic number would go below. So real quick, I just realized that I forgot one thing for this slide, and that would be a periodic table that we can refer to. Or hopefully you have your own. So I'm just going to take a quick picture. I don't think we need anything below, so there we go. Cool. So calcium has an atomic number of 20, okay? So we would go ahead and write the 20 down here, and now your nuclear symbol is done, okay? Atomic number, we would write in 20. Mass number, you can pull from the name. You can pull it from the name, so this would have been 40. Number of protons, you're taking your atomic number, right? So that goes with that. Okay. Neutrons, all right. So this is the way I like to do it on my piece of paper if I was in class. I would basically look at this column. If I have something here and here, I'm good to go. I'm going to do 40 minus 20, because man, right? M minus A equals neutrons. And you would get 20 neutrons. Okay? Electrons. So remember, I told you, as long as it's neutral, so as long as we're not dealing with an ion, these two numbers should be the same. So you would fill in a 20 there. Okay? So that's for the calcium example. So let's go to the one that was mean on my part. Okay? Let me just get rid of that. We'll put that over there. Okay, there we go. All right, so for this chlorine one, I'm going to kind of write in this white space down below. Okay, so you were given chlorine 35 ion. All right, so to start with, we would put our symbol. Again, this is a hyphen, not a minus sign. So we would put 35 up here. That's our mass number. Our atomic number, we would refer to our periodic table. We would look at chlorine. Chlorine has an atomic number of 17. So moving that away. So we would put 17 below here. But this has an ion. How do we figure out ions? What is the thing changing with ions? You got to look at your electrons, correct? So we're going to come back to the part that is going to go right here. We're going to come back to that. We got to figure out the rest of the row. So now that we have that, okay, atomic number. We have 17. We found that on our periodic table. Mass number was given in the name, 35. Now we can take those two values. Nope, not yet, sorry. I jumped the gun on that one. All right, number of protons. Remember, these guys are the same, atomic number and protons. Now we can take our, and this is just to verify, you could have had your 35 minus 17 to get you 18. Another way we could have done mass number. So let's just say, looking at this, you're like, yeah, I don't know. I have no idea. I don't know what to do here. Or let's just say I didn't give you this name right here. If I didn't give you that information, you wouldn't have known your mass number yet. So the way to do that backwards, and you've hopefully had a few examples of that, is you could have taken this 18. We knew we were dealing with chlorine, so that's 17. Add them together to get 35. So do you see that you could have worked it backwards as well? Yes, I'm seeing nods. Okay, cool. So that's the other thing. The other way to use this table is you can go forwards or you can go backwards. You do what you got to do. You kind of figure out your method on your own, okay, and what works for you.
So I got a question.
Yes. Correct. Correct. The ion part, I wouldn't expect you guys to do that yet. By December, you'll be able to do it. You'll know what it is. But other than that, I would have had to give you the electrons to figure out the ion part. So I would like to go over real quick that ion part because we still have to fill in this number right here. Okay. So I'm going to write that down below. I'm going to write it in green, okay? So using this number and our protons, we're going to figure out our charge. That's what I'm going to show right now in green, okay? So what you would do is you have your 17, so just like I was kind of finishing class with yesterday, we have 17, and then I say plus a negative 18. So that value had to be given to you. There would have been no other way to figure that out, okay? So 17, and you would have had a minus 18, and that gives you a charge, or an overall. If you were to type that in your calculator or do it in your head, you would get a negative 1 charge. This value is what's going to go right here. Okay, so your ion, let me zoom out a little. Here we go. So your ion has a negative 1 charge. So that final answer, I'm going to rewrite it down here so that it's not so cramped up in that little box. But you would have had a 35, a 17, and a minus 1. And that would have been your nuclear symbol for your ion. And you'll be able to do that. So that is how you, basically this last step, so this part and this part are how you're running the table down below. Okay? Does that kind of make sense a little bit? So what I'm going to do is I'm going to go ahead and say that we are over like 5 minutes. So I will let you go if you're going to go. If you would like to stick around and see a couple more examples or ask me about specific examples, we can do that. But hopefully that kind of helps clear up a couple things from yesterday. I know that was a tough assignment. I also recorded this just now, so I will, I'll be posting that so you guys have it to refer to also, okay? Okay, so it's going to be number 47, okay? So we can automatically plug in our atomic number. Oops, there you go. Okay, and that tells us, that we have 47 protons, so that's going to be important. Neutrons, how are we going to figure that out? Just like above, what we're doing up there, you have your mass number minus your protons to give you your neutrons. So 107 minus 47. 60? Yes? I can do math. I think my brain is fried though. 60, correct? Is that what you guys got? Just nod or no? Okay, cool, thanks. All right. All right, so we have our mass number minus our protons gave us our neutrons. And then we have our number of electrons. So that's going to be the part that you focus on for this ion symbol part. Okay, so we have 47 protons, 46 electrons. So the first thing to look at is who do you have more of? We have more of the protons, right? More of those. So what that tells us is that we're going to end up with a positive charge. That's why you analyze that first, to make sure you got that. So we're looking to have a positive charge. So the way we would handle this, kind of looking at the little equation method here, we would have our 47 plus a negative 46, meaning 47 minus 46, we would get a plus 1 charge. And that right there, that charge, just like above, so let me write it in pink. So we would have our silver, which is Ag. We have, oh, we're not writing it in nuclear notation, sorry. So we have our ion symbol or whatever. We would have silver, and then we would add in that little plus 1 right there. Does not look like a plus 1 at all. Hold on 1 second. Okay, what? You okay? There was a quick question about this one right here. That is an Al, and it has a plus 3 charge, okay? It says 3 plus, but it's plus 3 charge. So if you have your atomic number of 27, right? 27 is the number of protons. We want to know what are we putting there in order to make it have a +3 charge. Or think about it, right? So if that equation just overwhelms you and you're like, okay, because it's just like me putting x right there, right? So solve for x, just like in math class, right? So if that is overwhelming for you and you don't know, you're not really comfortable with solving for x from algebra and stuff, the other way to think about it is, okay, this is a positive charge. That tells me there's more protons than electrons. So I need to have 3 less electrons or 3 more protons. So that should, in your head, should be 24. So you're going to have 24 electrons here. Does that make sense? Kind of? So it's another way to think of it. Okay. So I'm going to stop this little recording.